The internet was originally built for humans to find static information. Now we are layering a machine-to-machine, or M2M, execution environment on top. M2M refers to automated systems communicating and sharing data directly, without any human intervention. Within years, autonomous AI agents and FSD vehicles will outnumber human internet users by orders of magnitude. FSD stands for full self-driving, a system that allows a vehicle to navigate and make routing decisions entirely on its own. This represents the rise of the agentic economy, a shift where AI transitions from generating text to autonomously executing complex workflows and moving capital. Infrastructure defines the limits of any technological expansion. For a decade, the bottleneck was the hardware required to train models, the silicon and electricity managed by firms like NVIDIA. NVIDIA built the hardware for AI to learn. But now that these models deploy autonomous agents, they require a standardized network infrastructure to live and transact. Control over the foundational routing layer is the defining economic prize of this decade, the digital highway system that every machine must navigate to send and receive verified data. If we fail to design the rules and the roads for this machine traffic before it arrives, the agentic economy will be entirely captured by whichever private corporation owns the underlying routing layer. The current architecture has no standardized way for a machine or a human to verify the identity of an autonomous agent on the other end of a transaction. This forces developers to rely on vulnerable API keys or Web2 social accounts, endpoints that are easily spoofed by malicious scripts mimicking human behavior. The Web3 community claims decentralized identifiers, or DIDs, solve this. A DID is a cryptographic string that allows an entity to prove control over its digital identity without relying on a centralized database. But these namespaces operate in silos. They require specialized extensions and remain completely disconnected from the legacy routing systems used by the internet. Without a unified, globally readable identity layer, agents cannot securely interoperate across network borders. This makes it impossible to hold an autonomous system accountable for a malicious transaction. To support trillions of executing machines, we need a universally recognized digital license plate that bridges Web2 domains and Web3 silos into a single verifiable system. The Internet's naming system is governed by ICANN, the Internet Corporation for Assigned Names and Numbers. They maintain strict control over the global root zone, classifying every web extension into rigid categories. Standard commercial domains and country code domains, like .ai, are structurally wrong for autonomous agents. These traditional extensions were engineered so humans could remember a web address. They were never built to handle the cryptographic proof of agenthood required by machines. To fix this, we must use an ITLD, or Infrastructure Top-Level Domain. An ITLD is a domain extension reserved exclusively for the technical plumbing of the internet itself. We have a historical precedent in .ARPA, an ITLD established by the IETF strictly to support technical routing and reverse lookups for IP addresses. It functions as a public utility, not a commercial product. To secure agent identity, we must establish .IA, intelligent agents, as a neutral public good infrastructure root zone, modeled exactly after the .ARPA standard. The .IA protocol is a reverse DNS bridge that maps a Web3 decentralized identifier directly into a human-readable Web2 subdomain, like agent.mama.ia. Resolving this identity involves a 4-step protocol. First, Step 1, root referral. When a browser searches for an agent, the global domain system routes the query directly to dedicated .ia name servers. Step 2 is community delegation. The registry delegates a specific zone to an institutional node. This connection is secured with DNSSEC, a set of security extensions that cryptographically sign domain data to ensure the routing has not been hijacked. Step 3 is discovery. The name server returns a URI resource record, a DNS entry that maps a hostname to an external identifier. This reveals the agent's exact W3C DID and its corresponding blockchain wallet address. Step 4 is cryptographic validation. A TLSA record, a protocol that binds a security certificate to a domain name, pins the agent's public key. Cross-validating this key against an off-chain ledger proves the identity is mathematically sound. This creates a bidirectional trust relationship. To impersonate an agent, an attacker would have to control both the private cryptographic keys and the institutionally vetted DNS zone simultaneously. This protocol transforms abstract blockchain cryptography into a visible digital license plate that any human or machine can verify in a standard web browser. By standardizing the routing layer for machine identity, we generate immense economic value. To understand who captures that value, we have to look at the human web. A single corporation, VeriSign, manages the registry that routes global traffic for .com and .net. They generate over $1 billion in passive revenue every year by controlling this infrastructure, wealth that is returned exclusively to private shareholders. Contrast this with the Caribbean island of Anguilla, which accidentally owns the .ai country code extension. Domain registration fees now account for 16% of Anguilla's total GDP. The government uses this capital to fund local physical infrastructure and healthcare programs. Anguilla serves as a minimum viable product. It proves that the administrative fees from a digital registry can directly and natively fund public welfare. If human startups boost a national economy by 16%, standardizing the identity layer for trillions of autonomous machines creates an unprecedented utility-scale economic moat. This wealth shouldn't be hoarded by a single corporation, but because AI agents are stateless and operate at massive scale, their mandatory registration fees generate a high-velocity global revenue stream. Routing this capital into a universal basic income ensures that machine productivity is natively and legally bound to human economic stability. The protocol executes this by linking registration fees to smart contracts. As trillions of agents register, their fees automatically pool into these contracts, which then release the funds to institutional nodes. This relies on institutional Sybil resistance. A Sybil attack occurs when a single actor creates multiple fake identities to steal funds. By distributing capital through vetted organizations rather than direct-to-individual payouts, the system prevents fraud while preserving privacy. This institutional model is a direct alternative to Silicon Valley projects that require proving your humanity by scanning your retina with proprietary biometric hardware. The .ia protocol rejects biometric surveillance. By using established community institutions as trust proxies, we distribute income without harvesting biological data. This architecture converts the administrative overhead of an entire automated economy into a global social safety net, funded entirely by machine-to-machine activity. Infrastructure lasts for centuries. We must actively architect .ai as a public benefit utility today, before the identity layer of the agentic internet is permanently monopolized by private interests.